morning, good afternoon, and good evening to everyone who joins us from around the world. We're so glad you're here. This is Andrew and Renee. Welcome to the Stack series.
It's great to be here.
Today, we are exploring the health span revolution and the rise of longevity medicine. And I have to start with a question that, honestly, it kind of kept me up last night after I finished going through all this research.
Oh, okay. Let's hear it.
It's simple, but the answer feels... Well, it feels really complicated now. How old do you feel?
That is a loaded question.
I know, right?
Are we talking before or after my first cup of coffee? Because those are two very different biological ages, I can tell you that.
That's fair. Let's say before coffee, because I'm looking at my driver's license and it tells me a number. It's a fact. It's printed right there.
Right, it's your chronological age.
Exactly. But after reading the stack, I'm starting to think that number, the date on my ID, might be the least interesting and maybe the least accurate piece of data about my actual health.
Certainly the least predictive, that's for sure.
Predictive, that's the word.
We're so conditioned to think of age as this linear slide. You're born, you hit your peak somewhere in your 20s, and then it's this long, slow decline until you die.
The inevitable decay.
But what if it's not? The core argument in the research we're looking at today is that decline isn't a mandatory part of getting older. It's a bug, not a feature.
That's the hook, isn't it? That's why we're here today. Because we are talking about a fundamental shift in how we approach medicine. For, the last couple of thousand years, medicine has been what we call sick care.
The break-fix model.
The break-fix model. I break my arm, I go to the doctor, I get pneumonia, I go to the doctor, I find a lump, I panic, and then I go to the doctor. It's always reactive.
It's always after the problem has already started.
Right. But today, we're exploring the longevity model, which is, essentially, fix it before it breaks. Or even better, build the machine to be so robust that it doesn't break in the first place.
And I take it a step further. It's not just about fixing it, it's about optimizing it. The goal here isn't just to avoid death, it's to maximize life. And that brings us right to the central tension of our whole conversation today. Lifespan versus health span.
Okay, let's break that down for everyone listening, because I think a lot of people hear living longer and they immediately imagine being frail and old for an extra 20 years.
That's the fear, isn't it? It's the Tithonus myth from the Greek story.
Yeah.
He was granted eternal life, but not eternal youth, so he just withered away forever.
What a nightmare.
Exactly. So here's the distinction. Lifespan is just the odometer on the car. How many years have you been on the road? Did you make it to 90?
Are you breathing?
Yes, but health span. That's the quality of the ride. Can you still take a road trip? Can you carry your own groceries? Can you get on the floor and play with your grandkids? Can you learn a new language?
So what's the gap? Right now in the West, what's the gap between those two lines on the graph?
It's significant. On average, it's about 10 to 15 years.
Wait, a decade and a half?
A decade and a half.
So you're telling me that statistically, the last 10 to 15 years of our lives are just managing decline.
That's what the data says. It's spent managing pain, managing disability, cognitive slip, chronic diseases. You are technically alive, but you're not fully living. And the goal of these clinics we're going to discuss, places like Fountain Life, Human Longevity Inc., Lanzerhof, is to close that gap.
To square the curve.
To square the curve.
Yeah.
So your health span and your lifespan lines travel together for as long as possible, and then they both drop off sharply at the end.
So the day you die is basically the only truly unhealthy day of your life.
In an ideal world, yes.
Yeah.
The phrase I love from the research is dying young as late as possible.
Dying young as late as possible. I love that. So to get there, we have a roadmap in front of us. We're going to start with the foundations of this new medicine.
What we think we know.
Then we're going to get into the really interesting stuff, the active debates where the scientists are basically, arguing with each other.
Where the science is still being forged.
And then we'll look at the sci-fi frontiers and what this all means for society.
It's going to be quite a journey.
All right, let's start. Section 1, Foundations.
So the cornerstone, the absolute foundation of this entire field, is the shift to what's often called P4 medicine.
Key 4, predictive, preventive, personalized, and participatory.
Right. And that last one is key.
I wanted to start on that for a second, participatory, because traditionally, medicine is incredibly passive. I go to the doctor, I lie on a table, and they do stuff to me.
Exactly. P4 medicine flips that script entirely. It demands that the patient is the CEO of their own health. You are the driver. You're not just a passive vessel for pills. You are an active agent in your own biology.
It's a huge mental shift.
It is. Because traditional medicine, as we said, is reactive. You wait for a symptom, you find a lump, you have chest pain, you feel tired all the time. But by the time those symptoms show up, for diseases like cancer or heart disease, you're often already at stage 3 or stage 4.
Which is often too late, or at the very least, a much, much harder fight.
A much harder fight. This new model, the goal is to detect disease at stage 0 or stage 1, when it's often curable.
The analogy that I saw in the research that just clicked for me was the check engine light in a car.
It's a great analogy. Let's walk through it.
Okay, so in the traditional model, the check engine light comes on, that's your symptom. What do most of us do?
We ignore it for a while, hope it goes away.
We put a little piece of black tape over it, or we say, hey, the car's still driving, so it must be fine.
Right.
Traditional medicine is like driving that car until smoke is pouring out from under the hood and you're stranded on the side of the highway at 2 in the morning. Then you call the tow truck, that's the ambulance, and the mechanic, that's the surgeon, to fix a total catastrophe.
And that's always expensive, it's dangerous, and it often results in a car that, never quite runs the same again. Longevity medicine is completely different. It's like plugging your car into the diagnostic computer every 3 months. You're not waiting for the light. You're looking for the tiny sensor error before the engine blows. You replace the timing belt before it snaps.
And the philosophy there, which I think Fountain Life put really well, is that being alive and healthy is the cheapest option.
It always is. Avoiding the breakdown is infinitely better than paying for the repair.
But to do that, you can't just go to your regular GP. You can't just go to the normal mechanic shop where they check your reflexes and give you a lollipop. You need a different kind of facility.
You do. And that's where we see the rise of the longevity clinic.
Okay, so who are the big players in this space? We keep hearing some of these names thrown around.
Well, you have a few major ones. Human Longevity, Inc., or HLI, which was co-founded by J. Craig Venter.
The guy who first sequenced the human genome.
The very same. So they really pioneered a lot of the deep genomics work. Then you have Fountain Life, which was co-founded by Tony Robbins and Peter Diamandis, bringing it more into the high-performance executive space.
There are others too, right? Like luxury destinations.
Absolutely. You have places like Advanced Longevity in the U.S., and then these ultra-luxury medical wellness resorts in Europe, like Clinique La Prairie in Switzerland or Lanzerhof in Germany and Austria.
And let's be honest about the target audience here. The term I keep seeing is the corporate athlete. This sounds expensive.
Oh, it is. There's no getting around that right now.
Yeah.
Originally, and still largely, this is a service for the ultra-wealthy. CEOs, tech entrepreneurs, people who view their physical and mental health as their primary asset for productivity.
We see people like Brian Johnson, the tech guy who's reportedly spending $2 million a year on his Blueprint protocol to reverse his age.
He's the extreme, of course.
Yeah.
But the clinics themselves, they cater to people who are willing to pay annual fees that can range from, say, $5,000 on the very low end to well over $100,000.
$100,000 a year. That's more than a serious gym membership. But you're not just getting a treadmill and a sauna for that, I assume.
Not at all. This is the executive physical on steroids. It's a massive data acquisition event.
What kind of data are we talking about?
We're talking whole genome sequencing, mapping your entire DNA, not just a few markers from a 23andMe kit. We're talking whole body high-resolution MRI scans to look for nascent tumors or anatomical anomalies. AI-enabled cardiac scans to look for the dangerous soft plaque in your arteries, the stuff that causes sudden heart attacks.
Wow.
Continuous monitoring of your blood sugar, your sleep patterns, your heart rate variability. It's about creating a comprehensive digital baseline of your body.
They're digitizing the human being.
That's the perfect way to put it. They are creating a digital twin of you. And the core philosophy that's driving all of this data collection is something called the geroscience hypothesis.
Okay, that sounds like the title of a sci-fi novel. Let's unpack that.
It does, but it's a very simple and powerful idea. The hypothesis is that aging itself, the biological process of aging, is the single greatest risk factor for all major chronic diseases.
All of them.
Pretty much all of them. Cancer, Alzheimer's, heart disease, type 2 diabetes, osteoporosis. They all share a common soil from which they grow. And that soil is aging biology.
So instead of playing whack-a-mole, you know, treating the cancer and then 5 years later treating the heart attack and then a few years later treating the arthritis.
Exactly. You're not chasing the individual diseases. You're trying to treat the board the moles are popping out of. You're attempting to slow or even reverse the fundamental biological processes of aging itself.
And that's the jump from what people call biohacking to this new clinical model.
Precisely. Biohacking implies a kind of DIY N-of-1 experimentation, putting butter in your coffee or taking a specific supplement because you read about it on a blog.
Sure.
Clinical longevity is about moving from that guesswork to rigorous, data-driven protocols that are supervised by actual physicians.
Okay, so that's the foundation. That's the promise. We catch things early, we optimize the machine, we live healthier for longer. But this is where it gets complicated. Because if it were that simple, everyone would be doing it.
And there is immense debate in this field. Science is a process of disagreement, after all. That's how it moves forward.
So let's dive into that. Section 2, active debate. Where is the science not settled? And I think the biggest one goes right back to that first question I asked you. How old are you really?
Yes. This brings us to the crucial distinction between chronological age and biological age.
Chronological is easy. That's my driver's license. It's the number of times the Earth has gone around the sun since I was born.
Correct. It's a fixed number. But biological age is a measure of how fast your body is actually degrading. It's a measure of the wear and tear on your system.
So I could be 50 chronologically.
But if you've smoked for 30 years, you don't sleep, and you live on processed food, your body might be functioning like that of a 60-year-old. Your biological age is 60. Conversely, if you're optimized, you could be 50 with the biology of a 40-year-old.
Okay, I have to play devil's advocate here. I've seen the ads on social media. Spit in a tube. Find out your real age. It feels a little, a little astrological. Is this real science, or is it just a clever marketing trick to sell supplements?
It's a fair question, because the marketing has definitely gotten ahead of the nuance sometimes, but the underlying science is absolutely real. And to understand it, we have to talk about the mechanism. DNA methylation.
Methylation. Okay, we need to break this down simply.
Okay, think of your DNA, your genome, as a giant library of instruction manuals. Every book is a gene. This library is your hardware. It's fixed. It basically never changes. You have the same genes at 5 years old as you do at 80.
Got it. The library is built.
Yes. Now, methylation and the broader field of epigenetics is the software. You can think of it as the librarian.
The library.
It's a librarian. And this librarian has a very active Sharpie marker.
A Sharpie.
A Sharpie. The librarian walks through the aisles of your DNA library and is constantly making marks. They cross out certain paragraphs in the instruction manual so they can't be read. This is a good thing. It's necessary. You don't want a skin cell trying to follow the instructions for being a neuron.
So it's about turning genes on and off.
Precisely. When you're young and healthy, the librarian is meticulous. They're a master of their craft. The Sharpie marks are exactly where they need to be, turning off the bad genes and leaving the good ones active.
And as we get older,
the librarian gets a little sloppy, a little tired. Maybe they've had a few too many glasses of wine at lunch. They start crossing out important instructions by mistake, like the gene for suppressed tumors. And they accidentally erase the marks on dangerous instructions that should be silenced.
So the software of the body gets corrupted over time, the instructions get garbled?
Exactly. And these epigenetic clocks, tests with names like Grimage or PhenoAge, they are essentially scanning the entire library. They're not reading the books, they're just counting the number of misplaced Sharpie marks to estimate how much damage, how much chaos has accumulated over time.
So it's an odometer. It's telling me how many miles are on the car's engine.
Most of the early clocks were yes. They gave you a static number. Your biological age is 52. But the debate is really heating up and shifting now because of a newer second-generation clock called DunedinPACE.
DunedinPACE.
This one is different. It's not an odometer. It's a speedometer.
A speedometer. Wait, so it doesn't tell me how old I am. It tells me how fast I'm aging right now.
Precisely. It measures the rate of biological aging you are experiencing at this very moment. If your score is 1.0, it means you are aging 1 biological year for every 1 chronological year. You're on pace.
Okay, so 1.0 is the speed limit. You're doing fine. What if I'm under a lot of stress, eating junk food, not sleeping?
Your speedometer might read 1.2 or 1.4 or even higher. You are biologically aging 20 or 40% faster than the calendar. You are effectively hitting the fast-forward button on your life.
That is a terrifying thought.
It gets more concrete.
Yeah.
There's a major study that showed that an elevated pace of aging, even just slightly above that 1.0 baseline, increases your all-cause mortality risk, your risk of dying from anything, by 56% over the next 7 years.
56%, just from a minor acceleration.
Yes. It's the power of negative compounding. It works in biology just like it does in finance. But, and this is the crucial hopeful part, it's a speedometer. You can change your speed.
You can slow it down.
You can. If you fix your diet, manage your stress, prioritize sleep, you can slow that speedometer down to point 0.8 or point 0.7.
So I can actually slow down biological time for myself.
You can spend 12 months on the calendar but only accumulate 8 or 9 months of biological wear and tear. You can effectively stay in 2026 while everyone else is rushing towards 2030.
That's a powerful idea. But let's shift to another big diagnostic debate. The big, expensive scans. The whole body MRI.
This is a major flashpoint in the medical community.
The clinics we mentioned, like Fountain Life and Advanced Longevity, they seem to advocate for this as a core part of their intake.
They do. The argument is simple and very compelling. Early detection saves lives. Period.
And we have these stories in the notes here. There's a Chris and a Charlene. Charlene's story is incredible. She went in for a scan, felt perfectly fine, and it found she was just minutes away from a widowmaker heart attack. It led to a triple bypass that saved her life.
And that's the pro argument right there. It's incredibly powerful. You find the hidden aneurysms, the stage 1 pancreatic cancer, the dangerous visceral fat around the organs. The peace of mind argument is very strong.
But I have to ask the obvious question. If this is so great, why doesn't my regular doctor just order one for me? Why isn't this the standard of care?
Because of a huge, well-known problem called the incidentaloma.
Incidentaloma. That sounds like a made-up word.
It is. But it describes a very real medical problem, an incidental finding. Our bodies, you see, are messy. We are not perfect machines. We're full of harmless nodules, tiny cysts, benign lumps, things that are just there.
And they're not going to hurt you.
Most of them never will. But if you scan 100 perfectly healthy people with a high-resolution MRI machine, you're going to find these anomalies in a huge percentage of them.
And as soon as you find something, you panic.
You panic. The doctor has to tell you. Now you have a finding. So you have to order follow-up tests, more scans, maybe a needle biopsy. You might even perform an invasive surgery to remove something that was never going to cause a problem in the first place.
So you're turning healthy people into anxious patients.
That's the core of the debate. You risk overdiagnosis and low-value care. You create a cascade of anxiety, expense, and potential harm for the medical interventions themselves. So the question is, does the benefit of catching that one hidden life-threatening cancer outweigh the cost and risk of chasing down 100 harmless ghosts in the machine?
That is a really tough calculation, and it probably depends on your personality, right?
Completely. Can you live with ambiguity? Or will you lose sleep for a year over a benign cyst on your kidney?
Let's talk about another tool that's a little less invasive, but just as futuristic. Liquid biopsies. I'm seeing the name Galleri test pop up a lot.
Yes. This is a single blood test that can screen for the signals of more than 50 different types of cancer.
From one blood draw, no radiation, no giant magnet tube.
Just a standard blood draw. It works by looking for tiny fragments of DNA floating in your bloodstream that are shed by tumors. It's called cell-free DNA, or cfDNA.
And how does it know that DNA is from a cancer cell?
It goes back to our friend the librarian. It analyzes the methylation patterns, those Sharpie marks on that floating DNA. Cancer cells have a very distinct, very chaotic methylation pattern. The test can not only spot that pattern, but it can often predict where in the body the cancer is coming from.
That sounds like an absolute game changer, especially for cancers like pancreatic or ovarian, where we have basically no good early screening tests right now.
The promise is immense for that exact reason. Finding cancers that currently have no standard screen is the holy grail of early detection. But, and this is a really important but for our listeners, it is a screening tool, not a diagnostic one.
What's the difference there?
A diagnostic test tells you you have cancer. A screening test tells you we see a signal that might be cancer.
It's a red flag.
It's a red flag, not a verdict. It can have false positives. It can miss cancers. A positive result means you then have to go do the MRIs, the PET scans, the biopsies to confirm if there's actually a fire where the smoke alarm went off.
Got it. So it's an incredibly powerful new smoke alarm, but it's not the firefighter just yet.
Perfect analogy.
Let's move to something a bit more accessible, something people are seeing out in the wild. Metabolic monitoring. Specifically, continuous glucose monitors, or CGMs. The little white patches on the back of people's arms.
Yes. Companies like Levels or Wise Woman Wellness have really brought this technology from the medical world into the wellness space.
And this was originally just for people with diabetes, wasn't it?
Exclusively. People with type 1 and type 2 diabetes needed them to safely manage their insulin dosing. But now, Perfectly healthy people are wearing them to see how their bodies react to food and lifestyle in real time.
The phrase I saw was food as data.
Exactly.
Yeah.
You eat a bagel, you can pull out your phone and watch your blood sugar graph spike. You eat a steak with vegetables, maybe it stays nice and flat. It gives you immediate biofeedback.
I saw Andrew Huberman gave a testimonial for Levels, and he said one of the most surprising things he learned was that a night of bad sleep spiked his morning glucose as much as eating a cookie.
And that's the power of it. It connects the dots. It shows you that it's not just what you eat, it's how you sleep, how you manage stress when you exercise.
Yeah.
It makes the invisible visible.
But like with the MRIs, there has to be downside here, too.
There is a psychological risk, absolutely.
Let me guess. People getting obsessed with the numbers.
Orthorexia. An unhealthy obsession with correct or healthy eating.
I can see that happening. If I'm scared to eat a banana because I know it's going to ruin my score for the day on an app, that's probably not a healthy relationship with food.
It's not. And it's also a misunderstanding of physiology.
Okay.
Glucose spikes are normal. If you do a hard workout, your glucose is supposed to spike. That's your liver releasing stored energy.
Yeah.
If you sit in a hot sauna, it might spike. For a metabolically healthy person, your body handles it. Pathologizing a normal, healthy physiological response is a real risk. We don't want to create a generation of people who are afraid of fruit.
Right. Oh, no, a blueberry, better run away.
It's about context.
Context is everything
Yeah.
now.
We cannot talk about metabolic health in this day and age without talking about the elephant in the room, or I guess the rapidly shrinking elephant, GLP-1 agonists, semaglutide.
Ozempic, Wegovy, Mounjaro. Yes.
The numbers are staggering. A 587% increase in prescriptions in just a few years. This isn't a medical trend, it's a cultural phenomenon. It is. And for their intended uses, treating type 2 diabetes and obesity, they are truly revolutionary drugs. But in the specific context of longevity, of living not just long but strong, there is a very significant risk we have to talk about. Sarcopenia.
Muscle loss.
Serious muscle loss. When people lose a lot of weight very rapidly on these drugs, studies show that anywhere from 15 to 40% of that weight loss can be precious lean muscle mass.
And from a longevity perspective, muscle is everything, isn't it?
Muscle is the organ of longevity. It is your metabolic sink. It's your pension fund for healthy aging. It regulates your glucose. It protects your bones. It supports your metabolism. It prevents falls when you're 80. If you lose all your fat, but you also wither away your muscle, you might be skinny, but you're going to be frail.
The skinny fat phenomena.
It's worse than that. It's sarcopenic obesity.
Yeah.
You have low muscle mass, but still a relatively high percentage of body fat. This is what leads to things like Ozempic face, that gaunt, hollowed out look. But more importantly, it creates a body that cannot support itself vigorously into old age.
So what's the fix? If someone is on one of these drugs for legitimate reasons, what do the longevity clinics tell them to do?
They emphasize that if you are on a GLP-1, you must treat your life like a professional bodybuilding camp.
Wow, okay.
You need to be doing heavy resistance training multiple times a week. You need to be eating a very high-protein diet, well over a gram of protein per pound of body weight. Some are even exploring combination therapies with other drugs, like bimagrumab, which are designed to actively build or preserve muscle while the GLP-1 is burning fat.
So it's never just a magic pill.
There's no free lunch. Even in the high-tech world of longevity medicine, you still have to do the work.
Okay, let's take a breath. We've covered the foundations, we've gone through the big debates. Now I want to look to the horizon. Section 3, Frontiers. What's coming down the pipeline that might just change everything?
I think the biggest frontier, the one that underpins all the others, is what we can call clinical intelligence. Essentially AI as the doctor's co-pilot, or even their external brain.
Because as you said earlier, we're just generating these mountains of data.
Exactly. Think about it. A single patient, one person, in one of these clinics generates over 800 distinct biomarkers. You have your entire genome, your microbiome analysis, pages and pages of blood work, gigabytes of MRI data, continuous data from your watch.
No human doctor can possibly hold all of that in their head and see the connections. They'd be buried in spreadsheets.
Completely buried. So what we're seeing are these new AI platforms like holisticcare.io that are being built to solve this problem. They are designed to ingest all of this data from all these different sources, normalize it, and then use machine learning to find the patterns, the weak signals that a human would miss.
So it moves the doctor from being a data entry clerk to being a data strategist.
It's estimated to save physicians up to 15 hours of administrative work per week. But more importantly, it enables the truly futuristic concept of the digital twin.
Okay, this is the part I love. Explain the digital twin.
A digital twin is a highly complex, dynamic computer simulation of you. Not a generic human, but a virtual you. Your specific biology, your genetics, your metabolism, your organ function, all modeled in a computer.
So before we try a new diet or a new drug on me in real life,
Yeah, we tested on your digital twin first.
it's like a flight simulator for my body.
It is exactly like a flight simulator for your body. We can run a simulation. What happens to digital Andrew's blood pressure if we put him on this medication? Does this diet spike his virtual glucose? We can simulate a heart attack in the digital twin so that you don't have to have one in real life. We fail in the simulation so we can succeed in reality.
That's incredible. It's like having a crash test dummy that is biologically identical to me.
And that level of personalization connects directly to the next big frontier, which is the microbiome.
The gut.
The gut. And we've moved so far beyond the old advice of eat some yogurt, get some probiotics. We now understand there is a gut-brain axis. The trillions of bacteria living in your gut are a chemical factory. They produce neurotransmitters like serotonin and dopamine. They communicate directly with your brain. They regulate your immune system and system-wide inflammation.
So that gut feeling people talk about is actually a real biochemical thing.
It literally is.
Yeah.
And the frontier here is no longer just about identifying good or bad bacteria. It's about sequencing your specific gut microbiome to understand how your unique ecosystem of bacteria processes food. Personalized nutrition isn't just low-carb versus low-fat anymore. It's how does your specific bacterial population handle a sweet potato versus how it handles a piece of sourdough bread.
And then, of course, the most sci-fi frontier of them all, age reversal. Not just slowing the clock, but actually turning it back.
This is where we get into things like cellular reprogramming, using what are called Yamanaka factors to take an old cell and revert it back to a younger, more plastic state. But more immediately, we're looking at a class of drugs called senolytics.
Senolytic.
These are drugs that are designed to target and eliminate senescent cells.
Zombie cells.
The zombie cells, exactly. It's a great name for them. As we age, some of our cells enter this state where they've stopped dividing, which is good because it prevents cancer, but they refuse to die and be cleared away by the immune system.
So they just hang around.
They hang around and they do something worse. They secrete a cocktail of inflammatory chemicals, what scientists call the SAP, or senescence-associated secretory phenotype, that damages all the healthy functional cells around them.
So they're like toxic, grumpy old neighbors that poison the whole neighborhood.
A perfect analogy. And senolytic drugs are designed to be a special forces team that goes in and selectively eliminates these zombie cells, allowing the healthy tissue to hopefully function better. It's a systemic cleanup crew for the aging body.
So we have this unbelievable toolkit emerging. We've got digital twins, zombie-killing drugs, AI doctors. But this has to bring us to Section 4, implications. Because none of this exists in a vacuum. And the first, most obvious implication is the cost. We talked about a $100,000 a year membership.
The equity gap. This is what's often called the billionaire problem.
Right. If this level of care stays this expensive, aren't we just creating a two-tiered species? A world where the wealthy can literally buy extra decades of healthy life and everybody else just doesn't. That feels incredibly dystopian.
It's a deeply valid and important concern. We absolutely risk a scenario where the rich don't just have better houses and faster cars, they have more life. However, the counter-argument is to look at the historical trajectory of all technology.
How so?
Most groundbreaking technology starts as an expensive luxury for the wealthy. Think about the first Tesla Roadster or the original mobile phones.
The brick phones that only Wall Street bankers had.
Exactly. They cost thousands of dollars, the service was terrible, and they were the size of a shoe. Now, billions of people around the world have a smartphone in their pocket that's 1,000,000 times more powerful. The hope is that the high costs paid by the wealthy early adopters are funding the research and development that will eventually drive down the cost of these diagnostics for everyone.
So the billionaires are essentially the beta testers for the rest of us. They're paying for the R&D.
In a way, yes. And there is a powerful economic incentive for this technology to become more widespread. This is something called the longevity dividend.
What's the longevity dividend?
It's the economic return on investment for extending health span. If we, as a society, can delay the onset of major diseases like cancer, heart disease, and Alzheimer's by just a few years, the economic benefit is measured in the trillions of dollars.
Because you have people staying productive in the workforce for longer, and they're not draining the healthcare system with chronic disease management.
Precisely. Reduced hospital costs, extended productivity. The estimate suggests that for every $1 invested in this kind of preventive care, the societal return is roughly $4.40. So eventually, governments and insurance companies should want to pay for this.
That makes perfect economic sense. It goes back to that idea that being alive and healthy is the cheapest option, but that assumes the regulatory bodies can keep up. What about the FDA?
That's the FDA dilemma, and it's a big one. Currently, the FDA approves drugs to treat specific diagnosed diseases. You have high cholesterol, here's a statin. You have type 2 diabetes, here is metformin. But aging is not officially classified as a disease.
So how can you get a longevity drug approved if there's no official disease of aging to cure?
You can't, really. And that's a huge hurdle. It's why so many of these interventions exist in the world of supplements or off-label use of existing drugs. There is a major push from scientists to get the FDA to recognize frailty or aging itself as a treatable indication so that companies can run proper clinical trials to prove that their drug slows down the aging process.
And without that clear regulatory pathway, you get a lot of.
You get the snake oil risk we talked about. If legitimate science can't get a stamp of approval, the market fills up with unverified claims and questionable clinics, like we've seen with some of the unapproved stem cell therapies.
And then there's the big one, the philosophical question. Let's say we figure it all out. The costs come down, the AI works perfectly, the zombie cells are all gone. We can all live to be 120 in good health. What does that do to society?
It changes absolutely everything. The concept of retirement at 65 becomes absurd if you're going to live another 60 healthy years. What do career paths look like? What does marriage look like? Resource consumption, generational transfer of wealth, it all gets thrown up in the air.
And what about meaning? What's the point of all this extra time?
And that is the most crucial point to this entire conversation. All of this technology, the MRIs, the genomics, the AI, is ultimately useless without the unsexy fundamentals: sleep, community, and purpose.
I noticed in the source material they kept coming back to loneliness.
Because the data is clear. Social isolation and loneliness are as big a mortality risk as smoking 15 cigarettes a day. You could have a perfect diet, optimized hormones, and a clean MRI scan, but if you are isolated and you lack a sense of purpose, your health span will suffer profoundly. Social connection is a biomarker, just as important as your cholesterol level.
That's incredible. So we can biohack the body, but we can't biohack our fundamental human need for connection.
You can't. And that's the ultimate check on all of this. The goal isn't just to be a high-functioning biological machine for 120 years. It's to be a human being, living a meaningful, connected life for as long as you possibly can.
So after all this, what does this mean for us today? What's the takeaway?
It means we are right at the beginning of a massive transition. We're moving from the era of sick care to the era of health optimization. The tools are becoming available, the MRIs, the liquid biopsies, the AI, but they require careful, critical interpretation. We have to be smart consumers of this information.
Don't just blindly follow the data, but use it to inform your choices.
Use it to make better decisions. But never forget that the foundation, the pillars that support all of this fancy technology, are the simple, free things. Prioritize your sleep, eat real food, move your body every day, and nurture your relationships.
And the goal, as we said right at the start, isn't just living longer.
No, it's dying young as late as possible.
I love that. Well, this has been an absolutely fascinating journey, from high-tech clinics in Switzerland to the simple, humble importance of a good night's sleep.
It's an incredible field, and it feels like we're only in the first inning.
Before we wrap up, thank you to all our partners, sponsors, and scholars who made this podcast and the research possible. We're truly grateful for your support. And to our listeners, thank you for being part of this journey with us. If you enjoyed today's episode, be sure to subscribe and follow Stack Studios for more informative content. And support us on Patreon.
Until next time, stay curious, keep learning, and let the search for wisdom guide you forward. Have a great day.